Hello everyone. In this video we're going to continue on with lesson 2 by describing quantitative data some more. In the last video we talked about the three main components of how you describe quantitative data, or at least that's what we ended with, and those three things were shape, center, and variability. We talked about shape the last time, and we're talking about center and variability in this video. So when we talk about measures of center, we're trying to describe an average value of the data. Okay, averages are extremely important in statistics, as we'll see later on, and so we're going to be very interested in what the average value or the middle of the data is going to look like. And so the three measures of center that we're going to take a look at, really we'll only look at two, but the three that most people know are the three M's: mean, median, and mode. You've likely seen these three things before in your academic career, but not unless you've taken a statistics class, probably in middle school or early high school. Or sometime else. So mean, median, and mode. We'll start out with the mean. The mean is by far the most popular measure of center. So the mean, described in words, is the sum of observations divided by the number of observations. Okay? In a mathematical equation, it looks like this. Okay? We're going to call the mean x with a bar over top of it, or x bar. Okay, so the mean is called x bar, and you sum all the observations up. So on the top I have a capital sigma, and sigma in math, the capital one at least, represents summing things. So I sum all the observations up, then I divide by n. The right part of the equation you don't need to worry about. I don't care that you know what sigma means. I do care that you know that x bar represents the mean. Okay, so if I will ask you for the symbol for x bar, and you should be the symbol for mean, and you should say x bar. Okay. The median is different than the mean. The median is the middle value of the observations when the observations are ordered from smallest to largest. Okay, again, this describes sort of the process of getting to the median. You probably remember doing this sometime before now. You order the observations and then you count inwards to the middle point, and that middle point is the median. Okay, we don't really have a symbol that represents the median, because it turns out the median is much less popular than the mean. Okay, so here are some properties of the mean that we are interested in. So the mean is called it is the balancing point of the data. So if you thought of the data sort of as a board, and you put under it a tipping point or a center, then the mean would balance that board. Okay, the median would not balance that board necessarily. Okay, so it's the balancing point of the data. It's usually not equal to any point actually in the data. So for instance, you often see that the average family has somewhere around 2.4 children. Okay, certainly you cannot have 2.4 children, but they report it anyway. So even though it's not possible, it is the mean. Okay, and it's still meaningful, even though it's not an actual point in the data. So if I ever ask for the mean, I do not want you to round. Do not round. Okay, for skewed data, the mean is pulled towards the skew. Okay, and similarly, the mean is highly influenced by outliers. Okay, outliers are unusually small or large observations. These last 2 points are a little nuanced, but they're also important. Okay, so when I have skewed data, oftentimes when my data is skewed, outliers are present. So this is an important term that I define in that 4th point. Outlier is an unusually small or large observation. Okay, the mean is oftentimes not a good measure of center. It's not. I shouldn't use it if I have skewed data and or outliers. For instance, if we as a class put together our earnings, okay, or we'll believe that you have been out in the job market making a decent amount of money, okay, and we all come back together and tell what our net worth is, okay, it's probably not going to be that different for all of us, and so the mean might be a good measure of the average person. Now if I come back and I add in Jeff Bezos, who is the CEO or is in charge of Amazon, okay, who is worth an enormous amount of money, and then I take the mean of all those points, he is going to raise the mean up by an awful lot because he is worth an awful lot compared to everyone else. And so that value, that mean value, is not going to be as representative as it was before I added that point in. That's not a good trait for the mean to have, but unfortunately it has it. Okay? That trait is called, or if you don't have that trait, you are what's called not a resistance measure. It means that you are not resistant to outliers, and we'll define that again later on. So we'll move on before I talk too much. The median. So the median is the other measure of center. It's the true middle of the data, and that's how we calculate it, is we look for the exact middle of the data. The median is resistant to outliers. So unlike the mean, the median is not influenced highly by outliers. So that's a good property of the median to have. So where would you might see this in the real world? Oftentimes in the census or in other places, when they talk about home values, they usually don't talk about the mean home value. They usually talk about the median home value. This is, of course, true because there are a few houses around that are worth an awful lot that can skew the home price quite a bit if I would use the mean to represent the average home value. Okay. Again, if this doesn't make sense, you'll do a reading, a little bit of reading on these things that will go into it with a little more depth and hopefully be a little clearer. Okay, so those are measures of center. Now we talk about measures of variability, or how spread out the data are. This is also very important in statistics. Okay, the first is sort of the naive measure, which is the range. You probably know the range. It's the largest value in the data minus the smallest value in the data. The range is not a very good measure of variability, okay, because it is really highly influenced by outliers. Okay, think back to my example with Jeff Bezos and everyone else in this class. If we took him out of the data set, the range is going to be much smaller than with him in the data set. Okay, so the range, not a great idea. The standard deviation is the one that we're going to work with a lot in this class. You probably have not heard of the standard deviation. A definition of the standard deviation is the standard difference between a data point and the mean of the data. Okay, so that probably makes it absolutely no clearer than before I read that. Okay. What you'll need to know, and what I'll show you in subsequent slides, is that it is one number that represents how spread out the data are, okay? And the larger the standard deviation, the more spread out they are. Okay, so here's a mathematical definition of the standard deviation. Again, I don't really care that you know the right part. I care that you know that the standard deviation is represented by the symbol S, okay, the Roman letter S, the one that we know. So lowercase s is the standard deviation. There's a third measure of variability that the book will talk a little bit about, and it's called variance. It is literally the standard deviation, which we just talked about, squared. Okay, I just square that number and I get the variance. You might ask, well, why do we care about the variance then? It has, the standard deviation has units associated with it, and so does the variance, and that can be meaningful in courses beyond this. Okay, so variance is the standard deviation squared, and so the symbol for variance is s squared, lowercase s squared. Okay, again, I don't care about the right-hand side. Now, properties of the standard deviation. This is the one that I want you to take home with you, so to speak. The greater the variability, the greater the standard deviation. Okay, if I have a standard deviation of 1, then there's relatively not a lot of spread in the data. The data isn't really spread out. But if the if the standard deviation is 100, then I know it's really spread out. Okay, so the standard deviation is non-negative, okay? It's usually positive, but there is the 0 case. And it's only 0 when all of the data points are the same in my sample, okay? If I have 2, 2, 2, 2, 2, 2, and 2, then the data aren't spread out at all, and so the variability, the standard deviation, is 0, okay? And like the mean, the standard deviation is affected by outliers, hence not a resistance measure. Okay, this keeps coming up, which means that it is important. Okay, so I want you to remember which measures are resistance measures and which aren't. Okay, so the mean is not, the median is, and the standard deviation is not. Okay. So now, again, your turn. So with the same data set, the same fuel economy data set that you had before, I want you to create some numerical summaries. I want you to find the mean of city, the standard deviation of highway, and then the median of dispel. Again, in the intro to StatCrunch video, I show you exactly how to calculate these. So look to that video for some explanation.